So today I'm going to talk about improving UEFI binary analysis within Ghidra. So I'm an offensive security researcher within Intel Corporation. I work in the data center group right now. I'm on the red team. I've been at Intel for about 6.5 years. And I first went there to do firmware security. So this has been kind of a natural progression, even though I've joined a product group. I'm still, kind of do a lot of their firmware analysis. Also, I want to put out a disclaimer that the talk and the work represented within is not a product of Intel, and should only be treated as research purposes. Intel does not endorse it or anything like that. So as we start, let's lay out the landscape a little bit. So most of you probably know, or maybe you don't. UEFI is the short little piece of, or it's actually a specification to initialize your hardware as it comes up and then hand it off to the operating system. So some of the key phases are on the right side of the diagram. In the pre-initialization phase, that's where your system's actually starting to power up. That's when your memory is actually established. As it'll transition, you'll hit the driver execution. That's where it's kind of setting up, starting to configure configure your device, etc. This is also when your management mode. So if you've heard of SMM, that's when it'll start setting it up. Towards the end of Dixie, into the boot device service stage, it will actually start programming security bits, and it will stop accepting settings for some things. It's where it'll apply the locks, and it's where it'll lock down your management mode. And then as you go to boot device select, you'll select your operating system. It'll begin tearing down your UEFI memory structures and handing off to the operating system. So when it actually hands off everything, you still have management mode, and there's still a UEFI table called runtime services, which is accessible. So why target firmware? Even though it's a small piece of when you start up, the computer, there's requirements on speed and efficiency. It's going to set basically the underlying security of your system. So if you get into if you can attack, the firmware, you can potentially brick it. You can give yourself persistence. Within the device, you can give yourself special operating privileges. And then what is binary analysis? So binary analysis is when you're going to take the machine level instructions, so this post compilation, and you're going to apply the specifications for what you're looking to analyze. And there's usually some repetitive steps, so there's there may be an entry point for the function to where you start decompiling, and you can figure out the rest of the functions within the program. If you can do this in a repeatable fashion, or you want to look at it, that's where we might want to look into automating. So why would we want to automate it? For consistency, for time saving, two big things. We'll talk about the build process in the next few slides, but the build process for UEFI is not necessarily straightforward. So even if you know what you're looking at, you may not actually know what you're looking at, and if you the binary that you're actually, the binary can actually tell a better picture than actually looking at the source code at times, or at least give you better pointers of where to look in the source code or what you should look for. So it can reduce time significantly if you can automate, some of the steps to it. So some of the ecosystem complexities. So the source code usually, so there's a EDK, there's a Tiana Core GitHub project or organization with EDK platforms. So those are public, those are open, and those kind of go, to what the companies are okay. There are a lot of specifications. Then you'll come to the manufacturers, so they'll have their own version of things, which can override some of the libraries within. And then you'll go out to vendors, and vendors will put some value add, so they'll have their own libraries, but the whole structure can look the same. So what are we actually looking at? When we're doing the binary analysis, you can look at the whole firmware volume, which is a combination of everything, or you can look at the specific EFI files or terse executable files. So the EFI file really matches a portable executable, so as long as you can, essentially, most of the binary analysis programs right now, if you say it's a PE, it can go through and do its normal thing. Terse executable is a little bit different because they modified the header, so not everything will recognize that by default. This was done for really size constraints because your whole firmware volume is supposed to be, a 16 megabyte chunk. And then, so the flash vault, so you have the EFI and the TE files. They're all placed together within a firmware volume, and then the firmware volume, there can be one or more that are combined into a flash device image. And if we step into kind of how the source is built real quick, so each one can have their own set of libraries and everything, but the configuration files are going to be within the left-hand side in green, the INF, the DEC, the DSC, and the FDF. And then there's a tools file which kind of tells you which build chain you want to use, so whether it's GCC, whether it's Microsoft compiler, etc. It'll go into a autogen process, which will then create your make files and everything. And then if you look at the top right in green, there's source code. So it takes the header files that actually runs make, like most people are probably used to, and that's where it's going to create the TE and the EFI files. And if perhaps it's not public code or whatever, you can also say I want to put in my own binary files. So all that goes into a process called image gen, which then creates the flash volumes and combines them into a flash image. So if you want to do UEFI analysis right now, there's various solutions out there. Two of the top ones that come up are Firmware Hunt and EFI Explorer if you're looking. So Firmware Hunt is more for like static signatures, so there are known problems out there. EFI Explorer is a IDA Pro based solution, so your mileage varies on getting licensing and everything for that. There is some Ghidra solutions out there right now. One's called EFI Seek. It actually does a pretty good job. It's written in Java, so they actually use the Ghidra plugin functionality to do it. And it recognizes the EFI files, not the TE files. And then I put up some other notable solutions. I believe, or I haven't really looked into the Binary Ninja, but I've seen that they've recently put out a few plugins that work. So why would we want to expand on Ghidra? Well, it's open source, so I don't have to pay for it anymore. I do have to trust where it came from, right? So for those, but that's up to you, whether you want to or not. But it does, within the APIs, you can use a Jython interface, which is Python, or you can use Java. There's trade-offs. So if you use the Python, you get to write it as a script, and you call it as a script. If you use Java, that you essentially have to make somebody compile the plugin and do a bunch of extra work. And that was one of the downfalls we saw with the EFI Seek solution. So as I was making modifications and trying to share my code with others, I couldn't just share the plugin because the plugin's unique per version of Ghidra. When I shared the code, they may or may not have been able to compile it. So there were just a bunch of problems there. So I found that moving it to Python was a lot easier. So I also found like it wasn't able to recognize some local variables. It didn't do a few things that we wanted it to. It didn't have the TE support, so and it didn't allow us to really automate like I wanted to, because I wanted to look at the individual EFI and TE files. It was more made for the GUI mode rather than the headless mode. So when you kind of take a step back and look at, you know, what are some of the steps involved within the UEFI itself and then within the framework, how can we build a better solution? So if I said I wanted to look at the EFI and TE files, I'm going to have to decompress them, you know, so I take the firmware image, decompress into firmware volumes, and then the individual EFI and TE files. Well, there's known programs that already do that, so Ghidra shouldn't have to worry about that. And certain things don't actually follow specifications, so if you take the off-the-shelf things that already do that, I can win there. Within Ghidra, so there's all the setup itself, but then for UEFI, that, you know, there's GUIDs, and then there's the structures itself, the header files and the structures themselves. So that can vary. So like I said, there's the public version, but then there's also, you know, manufacturer code and vendor code. So if I want to add any of that stuff special, it's not really easy within the current way of doing things. So how can I, you know, kind of make that better? And then as far as analysis, it's kind of straightforward in terms of, you know, you can identify the GUIDs once you know the entry point. You can kind of proliferate the various, so the system table has the runtime services and the boot service table. You can use those to kind of profile the rest of the file. And then if you keep track of the artifacts that you found, you can now do some analysis on it as well. And analysis is a little different than looking at signatures like firmware hunt, but looking at, you know, places that may be interesting to highlight, you know, as a researcher. And then finally, if I've looked at something already, is there a quick and easy way when I get the next version, the update, you know, the developers compiled something new, or, you know, new firmware update comes out, can I just do a quick diff to know where they changed things? So we'll kind of talk about a few of these things that we've done. So for the EFI and TE files, we found that CHIPSEC and UEFI tool are two of the main open source solutions. So if we can call them to have them do that, they do a really good job, but sometimes they're different. The results are different, so we can actually add some comparisons into it, and we can give feedback to those projects as well. We can take the results, we can put it in a file, so it's easy for Ghidra, you know, it's easy to then point to that folder and say, these are the files I want to analyze. I do want to note that if you happen to have the source code and you can compile with debugging symbols, having the artifacts, the GUIDs, the header files, and everything within Ghidra doesn't really matter as much because it already comes within the PDB files, so you can skip this step. So in addition to the normal installation and Ghidra setup, you have the GUIDs. So Tiano Core or EDK, they have a bunch of the DEC files that I pointed out earlier. Those GUIDs are all within the thing. So if I can parse that, I can create a GUID list. Also, some of the tools that we referenced earlier have their own GUID lists, which are from vendors. So if I can take that and combine it into a larger set, I have a more accurate or more GUIDs to look for. And then with the GDB files, I can actually parse the source, feed the header files back in, and Ghidra, most times, will go through and say, yes, I can add the structure. Sometimes there's some problems within the header files that you have to actually go manually fix. But that allows us to take not only open source, but then any new project or any closed source things that I have, you know, however I got them, and I can pull those in as well. So if it recognizes the GUID, within it you can actually apply the structures correctly, instead of just having an on-node GUID. I know this type of thing, but I don't know, what it's for. So we tried to create a script that allows you to easily do that, where you can just point it to the source code repos you want, and it'll kind of do all that for you, or within reason. So for the analysis piece, UEFI Seek actually did a pretty good job with everything. Its basic flow was really good. So we kept most of that, like I said, other than porting it from Java to Python. But then we added some new functionality to it because we were using Python. So one of my team members said, I have the SMI handlers for those of you that are more in depth with the knowledge of EDK. He said, why do I never get the correct SMI number? I always have to go back and look it up. So wouldn't it be nice to take, and as we're processing, that's part of one of the function calls. Can I gather that information and just put it in the code? Yes. Can I look for various? So once it's done processing, can I look for callouts better? Well, if I keep track of where the protocols are coming from, so if they are GBS, I can now say this is the SMI handler function. These are the functions that it calls. I can then look to see, do any of the references to my protocols go back or get referenced within these functions, opposed to just saying I'm going to look for GBS, or I'm going to look for So I can make it a little more specific in this case. Going back to the SMI handler, there's one of the function arguments is a context, which is called a COM buffer in most cases, where you're allowed to reference memory outside, so it acts as a mailbox. So if you do a check on that COM buffer, and then you dereference the memory again, so there's a potential time of use, time of check. So if I can utilize Ghidra to look for that specific case, I can now say, hey, go target this, or go look into this. And then with get and set variables, just knowing some of how it works. So with a get variable, am I checking the return? With a set variable, what is it actually setting? And can I gather any information from that? And then we also added some multiprocessing, so for the headless capability. So you're not just running one copy at once, you're running multiple copies. So here's just an example of the GUI. It's probably really hard to read, especially in the back. But you can see that it labeled I don't know if you can see it very well, but the handler actually got labeled, I believe, with hex like 23 opposed to 0. So you can see it actually labeled the handler number, so you'd know which SMI to reference if you're going to test it further, or if you wanted to test it further on the machine. Here's an example of the headless mode. So as I said, we created it so you can essentially dump all the EFI or TE files into a folder. As it's doing the headless mode, we create a log file for each one, and then a JSON file. So I'll go over some of the log contents, but it's basically the artifacts that we're talking about. Because I used the Python logger, you can now ship it out to whatever type of logging interface that you want to. You don't have to use the standard out. You can ship it to a database. You can do whatever. So some of the log contents, looking at the GUIDs again, the protocols, and then it just kind of shows some of the various things we talked about, potential callouts, and notify events, times the COM buffer was dereferenced. Here's some examples of the get and set variable, which ones were actually referenced, and then to do the kind of the regression testing, we took a snapshot of, ask Ghidra what its function hashes are for the functions, and then go through. And you can compare them, and you can say which functions actually, were in both analysis pieces, and you can get the list, and you can also take and say which hashes were unique within them, and you get the list. So if anybody's interested, we put it up on GitHub, so it's under the DC Red Team UEFI Surveyor. And then, yeah, thank you to the previous people that have done work within the UEFI space and some of my colleagues here.
Hey there, thanks for the talk. I was inspired to go see if I could do step 1, or maybe the pre-step to step 1 of, I've got my laptop here, I'm like, hey, how do I get my UEFI firmware volume?
Yeah, so on a lot of the vendor websites, you can go and you can actually get the update image, so it's the flash update.
Oh, but can I get the one from my actual laptop?
You can get the one from your laptop, so depend. Yes and no. So it depends on what it actually is, but so as I mentioned, CHIPSEC has a SPI dump, and there's some other programs that have a SPI dump, so that'll actually dump the SPI from your system. Also, if you're able to open it up and you can put the you can actually pull it off the SPI. So it depends how I guess creative you want to be, or how much you need it, but yes.
So, because I tried a disk-util listing and I see an EFI partition and I mount it, but it's full of empty folders. That's not the right thing?
No, that's probably gonna be a little different, yes.
Okay,
Yeah.
thanks.
Many years ago, the WikiLeaks had an article saying that they, I think, worked with Citizen Lab, and they had found a backdoor in the UEFI standard in the source code. Do you know if they've patched that, and do you know if anyone has actually released the proof that it was backdoored? Because they didn't, in the article, they didn't give the proof. They just mentioned that, long list of things that they had been backdooring.
I'm not sure which specific one you're referencing, but if you knew more specific, I could potentially tell you. Also, I know that, so not pitching anything, but Eclipsium is in the vendor sponsors area. You may go talk to them. They may give you a better answer as well.